Welcome to the online lectures for software engineering. In today's class, we'll be discussing how to build an analysis model. Now, the another name for analysis model, it is also called as the requirement model. Now, the main intent of analysis model is why are we designing an analysis model? And we are designing an analysis model because this analysis model, it gives you a description of whatever information is required by the system, the required information. Now it is going to give you all types of required information first. Then second, it is going to tell you about all the functions that are there within the system. And third is it is going to depict the behavior of the domain of a computer based system. That is the software that you're designing. So this is why we are designing an analysis model. Now coming on to the different elements of the analysis model, there are 5 different elements of the analysis model. This will also be covering within the lab sessions. So within this, the first one is scenario based elements, class based elements, behavioral elements, flow oriented elements, and analysis patterns. These are the 5 main elements of the analysis model. Now we'll first study what are the different UML diagrams. Now within the UML diagrams, you've got structural diagrams and the behavioral diagram. Now this behavioral diagram, they depict the behavior of the system, and the structural diagram, they show you the structure of the system. Now the structure, or we can say the skeleton of the system, how the software is being developed, that will be shown by the structural diagram, whereas the behavior will be shown by the making use of behavioral diagram. You've got use case diagram, activity, state machine or the state chart diagrams, sequence diagram, communication, and timing diagrams. These all fall under the category of behavioral diagrams. Now the sequence diagram, communication diagram, and timing diagram, these 3 diagrams, these are called as your interactive diagrams. I'll just write it here. These 3 are called as interactive diagrams. This is coming on to the structural part. These structural diagrams, these are going to have class diagrams, object diagrams, component and deployment diagrams. Now the first element of the analysis model, that is the scenario based elements. Now within the scenario based elements, by the name itself, scenario, it means that you're going to narrate a story. Within the scenario based elements, you've already seen the use case diagram. Use case diagram is a scenario based element. Now this scenario based, this system is described from the user's point of view. That is how the user thinks, what are the different functions, what are the different actors that are going to perform within the system. So that is called as the scenario based modeling. Now the first step within the elements of the analysis model is the use case diagram. Now when you get the description of the use case diagram, this is the, you can say, it is the first part of the analysis modeling that you're going to develop. Why it is the first part that you're developing? Because this use case diagrams or the scenario based elements, they are going to serve as input for creation of all the different elements of the software, for the creation of other modeling elements. This is for the use case diagram. I will see an example for use case diagram with for the scenario based elements. Within the scenario based elements, we are studying the activity diagram. Now within this, activity diagram, we know that this is a behavioral diagram. It shows the behavior of the system. Now within the activity diagram, you're going to have an initial state, not fill this with color. 1 second. This is your initial state. Initial state means the beginning. The next one, this is called as your final state. Then you're going to have this decision boxes. Then you're going to have an activity. Now this activity, it is going to be a rectangle, but it is going to have rounded corners. This is called as activity. So these are the 4 different elements of your activity diagram. So this activity diagram, it is basically, it is like a flow chart diagram that we have drawn in. For C programs, you've drawn different flowchart diagrams. So this is similar to the flowchart diagram. Now, by making use of this flowchart diagram, it is going to represent the flow from one activity to another activity, flow from one activity to another activity. Now, these activities, these are also described as the operation of the system. That is what specific task you're performing. That is called as your activity. Then one more thing is that you are also going to have arrows that is going to show you the flow of control. So these are the different 5 elements. Let's go back to now. Coming back to this activity diagram, within this activity diagram, within the previous class, we have studied eliciting requirements within the requirement engineering. We are taking that same example. What is eliciting requirements? Eliciting requirements is your requirement gathering. So this is your initial state. Then this is your final state. This is your activity. And these are your arrows. That is going to show you the control of information. Now within this elicitation requirements, these you're going to have a list of more tasks. Now within eliciting requirements, again, you're starting within the start phase. The first phase is conducting the meetings, and whenever you want to gather all the requirements, the first stage is you're going to conduct a meeting so that you can identify the different stakeholders, what are the different points of view. You can collaborate all the views. If you want to combine a few views, you can combine. A few views can be eliminated. Then you're going to make a list of all the functions and classes that are going to be there within the software. Now, when you know all the list of the functions and classes that you're going to make within the software, you also need to focus upon the list of limitations within the software, the list of constraints. Now, the constraints can be cost limitation, it can be technology limitations. Now, when you're identifying the list of constraints, you're going to identify whether there is any prioritization. That is, this particular feature, it is a top priority. It needs to be there within the software anyhow. A few other requirements, they might not have any prioritization, or they might have the least priority. If this is present, it is well and good. If it is not, then it is fine. So if there is any prioritization, if there is no formal prioritization, it means that informally you're going to prioritize a few requirements. If prioritization is then you're going to use the QFD. What is QFD? QFD is your quality function deployment that we've studied within eliciting requirements. There are 3 types of requirements within there that we've studied: normal requirements, expected requirements, and exciting requirements. Based upon this, you're going to prioritize the requirements. When your requirements are prioritized, you're going to make a use case. Now for developing a use case, again, there is a set of tasks. The first is there, you're going to define the actors, the list of actors, whether you're going to have the different primary actors and the different secondary actors you're going to identify. Then you're going to identify what is the goal of this primary and secondary actors. Based upon that, you're going to write the scenario, that is the different tasks that this primary and secondary actor is going to perform. Then you're going to fill in the template. Now the template is going to be the name of the use case that you're designing, the different actors, what are the scenarios, exceptions, that are all you're going to complete the template. When everything is complete, you're going to draw the use case diagram. Now that is the use case diagram is complete. So this is an example of scenario based elements. You can either draw the use case diagram. Now before the use case diagram, you're making use of the activity diagram so that you can depict a scenario. Now moving on to the second type of analysis model element, that is called as your class based elements. Now we have studied that class based element. This is what type of UML diagram? This is a structural diagram, that is, it is going to tell you the structure of a system. Now within this class diagram, you're going to make use of the class. Now this is a class. Now within the class, you're going to have three compartments. The first compartment, it is going to be the class name. The second compartment is going to be the attributes for this particular class. Within the third compartment, you're going to have the operations. Now you need to be clear in here that this class is going to have the sharp edges. That is, it is going to be a perfect rectangle. Now within the next diagram, we are going to see that this you're going to have rounded corners. So class is going to have sharp corners, a rectangle. Now within the class based elements, each usage scenario implies a set of objects that are manipulated as an actor interacts with them. That is, a set of objects that are manipulated. That is, if suppose within a use case diagram, you're going to have a customer that is transferring funds. Now when the funds are going to be transferred, it is going to reflect within his bank account. So in here, it is these set of objects are manipulated, that is, the account balance is manipulated. So within this, you're going to have all the interactions within the system, that is the entire bank model, how the user is interacting, that is going to be displayed by making use of the class diagram. Let's see an example for system. Now the system is your class name. Now for the system, you're going to have a system ID, that each system is going to have a unique identification number. Now you might have a verification phone number that is given with the system. The status of the system. Is there any delay time? Telephone numbers. Is there a master password? Temporary password? Number of tries that can be given for a wrong password that has to be entered. So these are the different attributes that are defining the particular system. Then you've got the operation, that are the different tasks that they are going to be performed. Now within this operations, every time you list an operation, you're going to give this brackets. That is, the system is used to program, it is used to display, reset operation, query, arm, disarm. Now this is the entire system, that the different attributes and operations that are performed by this particular system. Now this system, you might be seeing what is arm and disarm. Now if we've taken the example of safe home security function. Now the safe home security system, it is installed in homes where you want to secure your home from any intruder. So if you're selecting all the sensors, that is, when you have activated all the sensors, then your system is armed. Disarm means when you have deactivated the system, it is the disarm. So this is your class based elements. We'll see an example in here. That is, if suppose you're making a structure diagram for a floor plan, there's a class diagram for a floor plan whenever you're designing a particular floor. That is, within the floor plan, you're going to have different cameras, that is for security. You're going to have different walls. Within walls, you're going to have different types of walls. You're going to have wall segments, windows, and doors. For each and every class, you're going to have its attributes and the operations. Now if you see the door is going to have the type. If we see in here, the door has got the type of door it is, whether it is a plastic door, a wooden door. Then you're going to have the coordinates, dimensions, the starting, stopping coordinations, the next door. Then operation is, it is going to determine the type and you're going to draw that particular door. Here you're just making a floor plan. So you're going to make a door within its place. Then the same is going to be for a window. Then for camera, you're going to have the type of camera that are used for security, the CCTV footages that you'll be recording, the type, the ID of the camera, the location where this camera is recording, where you're going to have the field view or pan angle, whether you can zoom in. These are the different attributes. Now the operations for the camera is determining the type, the location, the display ID will be displayed, what type of view it is, whether you're going to have all this thumbnail display is going to be there, or whether you can zoom in the display. So these are different operations for the camera. Whereas for the wall, you're going to have the type of wall, the fall wall, the boundary wall, what type of wall you're using, the wall dimensions. Then you're going to compute all of those dimensions. Now you're making the plan, that is why you need to compute all the dimensions. Now this floor plan, this wall is a part of floor plan, whereas door, windows, wall segment, these are used to build a wall. So in here you can identify you're making a structure of an entire floor plan, whereas within this entire floor plan, this camera is a completely another part, whereas these cameras will be placed when this entire floor plan is developed. So these cameras are placed within the floor. So by seeing this example, it gives a clear picture of what a class diagram is used for. It is identified so that you make an entire structure of the system. The next is behavioral elements. Now behavioral elements, now in here you're going to make use of the state chart diagram or the state machine diagram. Now this is the representation of a state. This is how your state is going to look like. Now the class had corners, whereas this state is going to have rounded corners. Here you have narrowed corners, here you're going to have rounded corners. Again, you're going to have three compartments within the state. The first is going to be the name, second is going to be the different variables, and the third is going to be the different activities that are going to be performed. So the first one is, if you suppose you're reading any commands. When you're reading commands, the different variables is the system status message, it is going to be ready, as within the use case diagram we have seen. When you've entered, when you've activated all the sensors, it is going to be ready. Display message, if suppose you're entering the password, it is going to ask you to enter the password or any message. Means if you're entering the command, whether you're selecting the stay function or the away function, whether you're staying within the house, it is going to deactivate a few sensors. If you're moving out of the house, you're going to select the away function. Now that away function, it is going to activate all the sensors. So that is the message that is going to be displayed. Then the display status is steady. Then coming on to the activities, do poll user input panel, you're going to have a read user input panel and interpret user input. These are the different activities that are performed. That is, the user is reading input from this display status message and you can interpret the input. That is what it means. What does away means, what does stay means, that is interpreted by the homeowner. So this behavioral elements, the behavior of a computer-based system can have a profound effect on the design that is chosen and the implementation approach that is applied. Therefore, the requirement model must provide modeling elements that depict the behavior. Now, why we are designing this behavioral elements? Because whenever you're designing a state chart diagram, when you know the behavior of the system, as the name says, the behavior of the system, the state chart diagram, it is going to tell you how the behavior of the system is going to change. Now, when you know how the system is going to be changed, that is going to affect your design. What type of design you're going to select when it is being changed, how you're going to implement that design, how you're going to apply it. All of the key features need to be implemented. That is why you're designing a state chart diagram, so that you get to know the behavior of the system. Now within the behavioral diagram, you've got a list of different diagrams based upon the requirement. For user scenarios, you use the use case diagram. For behavior of the system changing from one state to another state, that is what is going to trigger the state of, we'll see an example for that. What is going to change one state to another state. Now, if we take an example, now this particular example is when you're placing an order. When you've placed an order, now when you've placed an order, the within the state chart diagram, you're going to have the same initial state, final state is going to be same. Now this you're going to have this arrows and you're going to have the same activities. Now within the in place of activity, you're going to make use of different states. Now within the state, you can also have this normal representation that does not have any compartments, or you can make use of one second, of a state that has got 3 compartments, where if suppose you want in detail representing all the variables and the operation, then you can use the 3 compartment view, or you can use your default one. Now within this initial state, you're placing a new order. When you're placing an order, a receipt is going to be developed, that is an invoice is generated. When invoice is generated, if you make a payment, then your order is going to be shipped. When your order is confirmed, that is if the parcel is being shipped, then it is going to be delivered to your home. When it is delivered, then this particular shipment tracking is closed. Whereas when the invoice is generated, if suppose you're just doing window shopping, when you're going to check the amount and just you're going to exit the app, then the order is cancelled. Then that is the end, that is your cancellation order. And if when the order is being shipped, that is also the final state. So this is how a state chart diagram, it is going to tell you what events, that is you can say when your invoice is generated, if you're making the payment, then you're going to change from invoice state to paid state. Whereas if you cancel the order, you're going to change from this invoice state is going to be changed into a cancelled state. So these are the messages that are triggering the change of one state to another state. Now this paid is one state, this on dispatch, this is a trigger that is changing from paid state to the shipped state. So this is the state chart diagram. The next is flow oriented elements. Now within this flow oriented elements, you can make use of flow chart diagrams so that you get to know how information is flowing from one part of the system to another part of the system. So the same thing is written, information is transformed as it flows from through a computer based system. The system accepts input in a variety of forms. Now within this flow chart, when you've got when it is changing from one state to another state, it is going to take input. So that input can be taken from many forms. And then it applies the functions to transform it and produce the output in a variety of form. That is, you're going to take several inputs, then you can perform some function, that is you can make use of a decision function, then it is going to generate an output. Based upon that, whether it is going to stop or some procedure is going to start again. That is flow oriented elements. Now, a more detailed description of flow oriented elements, this is within the next unit. Then the next one is the last element of the analysis model is called as the analysis pattern. Now the analysis pattern suggests solutions within the application domain that can be reused when modeling many applications. Now this, what are these solutions? These solutions, it can be a class, it can be a function, or it can be a behavior. So this is going to analysis pattern suggest the types of solutions that are within the application domain. This can be reused. That is analysis pattern. It focuses on reusing. Now within this, the analysis pattern template, the first thing that you're going to have is a pattern name. What is the pattern name? Pattern name, it means what name you're given so that it can give you the reference to pattern. By Seeing the pattern name, you can identify why this pattern was generated. You need to give a meaningful name. Then the next one is intent. Intent, it describes what this pattern actually accomplishes. What it accomplishes, that can be identified by the pattern name. Or you can say that what problem is addressed, that can be identified. Then going on to the motivation. Now this motivation, you can have a scenario like a story. You can say a story. Now this particular story is going to tell you how the pattern can be used to address the problem. How you're going to use the analysis pattern so that you can address the solution. Next one is forces and context. Now within here, you're going to have a description of all the external issues, the different constraints, how these external issues, how they are going to affect the pattern that you're going to use. Now this external issues, the example of external issues, it can be any technical constraint or any people related matter that people have imposed, that this is the constraint for the software, this technology needs to be used, this is the cost, this is the people that I want within the software to work. So these are the external issues, how that is going to affect the pattern. Then the next one is solution. Solution means how you're going to apply the pattern, how the pattern is applied so that you can solve the problem. That is your solution. Now, when you're giving the solution, how you're applying the solution, this also focuses upon all the structural and behavioral details. Also, this focuses upon all the structural and behavioral details. The next is consequences. Consequences means like what happens when the pattern is applied. What are the different trade-offs? What is trade-off? You get something by the loss of some other thing. So what are the trade-offs that can happen when you're applying the pattern, when you apply the specific pattern? The next is design. Design, it is going to have the different design patterns. For whenever you're designing a particular for a door, if you take an example of a door, there are different types of designs of door. There are designer doors, the normal doors, you've got plywood doors, different types of designs are there. So same way within this analysis pattern, you can have, like, you can discuss how this analysis pattern can be achieved by making use of design patterns, of different design patterns. Then the known uses where this pattern was used, you can have a list of different uses, or you can say the different examples also, examples of actual systems. The next is related pattern. Now related pattern means what are the similar patterns that you are going to use. Now whenever you have a solution to, whenever you're making use of some specific components or some specific patterns, you're not going to have only one example of it. Are going to have different related patterns that is going to solve the similar types of solutions. So you're in, like within the text, when you're referring the syllabus has got reference textbooks that you can access. First textbook is there, second and third. So that is going to have the related text according to your syllabus. So those are your related patterns. What are the related patterns that is identified? The similar ones. Now the next topic is negotiating requirements. Now what is negotiating requirements? Within the requirement engineering tasks, negotiation was one of the tasks within requirement engineering. Now with the negotiation, what happens with the negotiation? uh, the customer asks for more, then that can be achieved. That is when you have identified the specific task, when you have identified the cost, when you have identified all the requirements, you've made a schedule. When everything is decided, after that the customer or another stakeholder can come and ask whether can I get some additional requirement within this same cost, or whether this can be achieved within this, whether this can be delivered within the time schedule. That is asking for something more than that is being decided. That is called as your negotiating requirements. Now what happens when you're negotiating the requirements? Now whenever you're negotiating requirements, the few things that are going to happen is you're going to have all the users, the stakeholders, and all the customers. You're going to gather all of them. When you've gathered all those three people, these three people, they are going to be asked to prioritize the requirements. Now, prioritizing the requirements, it means that which ones are important. You're going to label them as 1, 2, 3, 4. This is going to go on. Now, what specific requirement that has got the highest priority, that is, it needs to be present within the software by anyhow, that can be given the highest priority. The ones that can be given, that are given the least priority, it is like this, it is fine if it is present, and it is fine if it is not present also. So that is prioritizing the requirements. Now, when you've prioritized the requirements, when all the users, stakeholders, customers, they have prioritized the requirements, you're going to identify where is the conflict in prioritization. Or you can say that you're going to, all the conflicts are identified. That is, if suppose one specific requirement is marked as 1 by user, and by the stakeholder it is marked as 3, so you're going to identify what are the conflicts. So based upon the user point of view, if it is the first requirement, then you're going to again make those conflicts, you're going to resolve the conflicts. When the conflicts are identified, you're going to resolve those conflicts. Now these conflicts are resolved by either deleting a few requirements, combining, or you can also add a few requirements. Now, why all of this is done? This all is done so that you can achieve some level of satisfaction between all the users, stakeholders, and customers. Now, this is what is negotiating requirements. So the same thing I've noted down in here. That is, in reality, you may have to enter into the negotiation with one or more stakeholders. In this case, all the stakeholders, these are asked to balance the functionalities, the performance, and the other product characteristics based upon priorities. Priorities, you're going to prioritize, and then you're also going to identify if there are any risks that are associated with them. And then what is the cost? That is how much money you need to put in to fulfill those requirements, and how much time will it take to produce that particular requirement. You're going to identify all of the things, and then you're going to make a list where you can combine, delete, or add the new requirements so that the stakeholders can be satisfied. So this is negotiating requirements. Now the best negotiation, it strives for win-win result. Now win-win result, it is for people that are the stakeholders. The win-win, it should be between the stakeholders and the members of the team, that are the people that are developing the software, members of the software team. It should be win-win between these two people. So that is the stakeholder wins by getting the system or product that is satisfied. That is based upon the prioritization. You get the same software, and you, that is called as the member of the software team, and you win by working with realistic and achievable budget and deadline. When you're making a prioritization, when you make a priority, you're going to identify the risk, the cost, and based upon the time to market, based upon all these aspects, you're going to develop a software that is going to be a win-win for the stakeholders and as well as the member of the team. This is negotiating requirements. Now, Bohum defines a set of negotiation activities at the beginning of each software process. Now, if you remember the name Barry Bohum, he designed with specific model. He have designed the spiral model. Now, this particular person, he has also defined a set of negotiation activities that you need to follow. First, identification of the system or subsystem stakeholders. You're going to identify all the stakeholders so that you can ask them to prioritize the requirements. Then determination of stakeholders win condition. That is, what is his priority that he can win. That is, if he wants specific requirements or he wants the software to be developed within the specific time, what are his win conditions? You identify that. It can be the time to market, or it can be any requirements. You are going to identify that. Then the third one is negotiation of the stakeholders win conditions to reconcile them into a set of win-win conditions for all concerned. That, as I've told you, there are conflicts within the different stakeholders. Prioritization. So you're going to negotiate between all the stakeholders and you're going to reconcile all of them so that you all of them have got the win-win conditions satisfied. Now, the successful completion of these three steps, that are first, second, and three steps, this achieves a win-win result, which becomes a successful software that is developed. The next topic is validating requirements. Now, what is validating requirements? To validate, it means that you're going to confirm all the requirements. You're going to confirm whether all the requirements that was stated by the end user, whether all of them are present within the software. All of these requirements are confirmed and they meet the system level of program. Now, what is going to happen while you're doing the validation of requirements? Now, validation requirements, it ensures that, first thing, that all the requirements that you've stated, all of those requirements are correct, all of them are complete, and they are consistent. That is, they are not changing based upon the specific time. The second one is you create the model that can be created. That is, whenever you're creating a prototype, this prototype, it satisfied based upon the prototype, you're going to design the main model. So this satisfies all the requirements that was stated by the customer. Then the third one is you're going to design a real world solution, can be built and test. That is, whatever based upon that model, whatever you're developing, the solution, the software that you're developing, it can be built and it should be tested. Now, this testing, it is the very important phase because it ensures that all the functions and features, they are executing well, so that you know that all the features are there and they are doing the correct job. They are achieving the specific level of performance. Now, each and every element within the software that you're designing, each and every element of the requirement model that you've created, you're going to examine if any inconsistency is there, that is, it is not complete, whether any informations were removed or not, omissions, and ambiguity, whether it means more than one thing. You're going to identify this. That is, you're going to examine the model for these three things. Now, a review of requirement model addresses the following questions. That is, whenever you're reviewing the requirement model that you have developed, it addresses the few things. What are those few things? is each requirement consistent with the overall objectives for the system product? That is, it's each requirement complete or not, you're going to identify that, whether all of the requirements are complete or not, and whether they do that specific task that was defined whenever you are having a meeting with a customer. Then the next requirement is, have all the requirements been specified at proper level of abstraction? What is the level of abstraction? Level of abstraction means the level of detail, how much detail is given for each and every requirement, whether all the requirements are specified or are explained in the level of detail that was required to explain them, or some more information is required that you are going to identify. That is, do software requirements provide a level of technical detail that is inappropriate at this stage? That is, within the first stages, what you're going to do, you're not going to have all the technological details. You're going to have that within the BP software process. We have seen that you're going to have the world view, then you're going to have domain view, element view, and detail view. Based upon that, at the analysis model, whether you're having all the inappropriate technical details out there or you're giving the brief description, you're going to identify that. Then the next phase is the next step is the requirement really necessary, or does it represent an add-on feature? That is, you're going to identify whether these are the, within the requirements you study three types: normal, expected, and exciting. So within what category this requirement falls, whether it is normal requirement, whether it is expected, or whether it is the exciting requirement, this is going to be identified. Now, based upon this, if suppose it is an extra requirement, that is an exciting requirement, this may not be essential. That is, it is not important if you have this particular feature within the software or not. You're going to, within the end, if suppose it is having any risks are associated with that, you can eliminate that requirement. The next is each requirement bounded and unambiguous. Now, what are unambiguous requirements? It means that one requirement, it does not have more than one meaning. And bounded means it is complete and it is fair. That is, each requirement is fair and it does not have more than one meaning. That is, it is unambiguous. Then the next one is, does each requirement have attribution? That is the source noted for each requirement. Now, source noted means within the requirement engineering, we have identified traceability tables. You've got one source traceability table. Source traceability table means why the specific requirement was identified, or you can say this particular requirement, it is a solution to what particular problem. It is a solution to what particular problem, why we are embedding each and every requirement, the source of each requirement, that need to be identified. Now, the source of the requirement is very necessary so that you can identify that the specific requirement, whether it is solving the problem or not. Then the next one is, do any requirements conflict with other requirement? Now, conflict means whether it is affecting some other requirement or not. You're going to identify that, whether one requirement is affecting another requirement. That is, suppose you're implementing one requirement, it is not easy for you to add another requirement. It is affecting another. That is, if one is there, the another cannot exist at the same time. Whether there is such type of scenario or not, you're going to identify that. Then the next one is each requirement achievable in the technical environment that will house the system or product? Now, this means that whether all the requirements that you've stated, whether they are realistic or not, that is, whether you can achieve them or not, that can be identified. Whether all the requirements are realistic or not, that will be identified. Then the next one is each requirement testable once implemented? Whether all the requirements that you're implementing, whether they can be tested or not, that will be identified. Now, if your requirements, whatever you're implementing, if you're unable to test them, then it will be waste for you, that you cannot identify whether it is working or not. So all the requirements that you're embedding, you should be able to test them so that you identify whether they are working or whether they are doing the specific job or not, whether it is implementing the specific functionality or not. Then the next one is, does the requirement model properly reflect the information, functions, and behavior of the system to be built? Now, within the requirement model means you're going to have all the requirements there. Now, within this requirement model, it should have all the information, that is, what components are used, what patterns are applied, what design is used. it should be there. And all the functions means what are the tasks you want the system to perform. Behavior means how the system is, how the external and internal factors affect the system. External and internal factors, how they are affecting the system, you get to know an idea of that. So you're going to check the requirement model so that it has all of this information within the system. Then the next one is, has the requirement model been partitioned in a way that exposes progressively more detailed information about the system? That is, whether you have split the particular problem into sub problems. That is, first you've got a problem, whether you have split it into sub problems. Now when you're focusing on one problem, if you split it into sub problems, that is, within one problem you're going to have different, there are three categories or four categories. When you have those three four categories, that is, you're going to have more detail about this particular problem, how you're going to address the particular problem, so that you're going to identify whether this requirement model, it is partitioned in a way that gives you more detailed information about the system. When you have different sub programs or sub components, it becomes even easy for you to work, and you have also got more detail of how you're going to implement the solution. Then the last is, have requirement patterns been used to simplify the requirement model? Now we are going to also study the different patterns. So what are the different patterns, and the patterns that you've used, whether those patterns are simplifying the model or not. Now the same way, if you're designing your home or you're designing your bedroom, you're going to have different patterns, you're going to have different views that you can design this your home, your room into. You have the different curtains that you can choose, the different sofa area, the different types of beds, how you're going to place the table across the room, everything, the different patterns, whether these patterns, they are simplifying the requirement model or not, that will be identified. Now when you've identified that, the next part is, have all patterns been properly validated? That is, if suppose you're making use one specific pattern in a particular room, that is, if suppose you're implementing a pattern where it requires a window within the room and your room does not have a window, then it does not fit into it. So you're going to validate the pattern, whether it is a better fit for your system or not. You're going to validate the system, sorry, you're going to validate whether this pattern is a fit for the system or not. Then, are all patterns consistent with the customer's requirement? That is, all the patterns, whether they are going to adhere to the customer's requirements or not, whether all of them are implemented by making use of that pattern or not, that is going to be identified. Whether all these patterns are complete. Consistent means they are complete. So this were all the questions that need to be answered for developing the analysis model. Now this is the end of the class. This concludes the requirement engineering chapter.